Let's try and find the derivative of an exponential function. So let's look at a basic one of a to the exponent x, where a is a positive integer. Now we can't use our power rules or chain rules, so let's go back to the basic definition of a derivative. So we're going to have f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now substituting in our function, we get the limit as h approaches 0 of a to the exponent x plus h minus a to the exponent x all over h. In the numerator, we can now factor out a to the exponent x, so we're left with a to the exponent h minus 1 in the numerator. Because a to the exponent x does not involve h at all, I can take it outside of the limit. So I have a to the exponent x times the limit as h approaches 0 of a to the exponent h minus 1 all over h. Note how we now have our original function being multiplied by some constant number. This means that our derivative is proportional to the function itself. Let's take a look at what f prime of 0 would look like. We would have the limit as h approaches 0 of f of 0 plus h minus f of 0 all over h. So that would give us a to the exponent h minus 1 all over h. This allows us to conclude that f prime of x is equal to a to the exponent x multiplied by f prime of 0. So we now want to see if we can find an exponential where f prime of 0 is equal to 1, because that would allow us to say that the derivative is itself. So what we're trying to look for is the limit as h approaches 0 of a to the exponent h minus 1 all over h equals 1. If I multiply both sides by h, I get the limit as h approaches 0 of a to the h minus 1 equaling h. So I move the 1 over and I get the limit as h approaches 0 of a to the exponent h equaling 1 plus h. Now we're going to do something a little tricky. Let's let h be equal to 1 over n. So this means as n goes to infinity, h is going to 0. So we have a to the exponent 1 over n is equal to 1 plus 1 over n. And I haven't changed anything because it's still going to 0. I'm just looking as n goes to infinity instead of as h goes to 0. Now let's bring both sides to the exponent n. So this leaves us with a is equal to 1 plus 1 over n all to the exponent n. So let's do a kind of guess and check here. Let's look at n and then look at what 1 plus 1 over n to the exponent n would look like. So let's start with n equals 100. If I plug 100 into that equation, I get approximately 2.705. Now let's go larger than that. Let's plug in 1,000,000 into the equation. I get approximately 2.718280046. Now you can keep plugging in larger numbers of n, and you'll keep getting a number that's actually going to be really close to 2.718, so on and so forth. This number is actually a special number in math, and it's the number e, which is approximated to 2.718. So we can see that as n goes off to infinity, a is approaching this letter e. Let's continue finding the derivative in the next video.